Hello friends, hope you all are in very good health. Well, happy weekend to everyone. Today is Saturday. This weekend I am going to take you through the next chapter of Biostatistics, which will be regarding data. I will be telling you regarding various presentation of data for both qualitative and quantitative data, and various diagrams which will be useful in various competitive exam to crack the image-based question. We shall be understanding how to present the data. We shall master how to prepare various charts, and it will be fun. So let us hope that all of you will join and enjoy the video. So see you through the video. Hi, so let's start the discussion on sources and presentation of data. So what are the data sources? Data sources can be primary data source, data generated for a specific purpose, such as experiments, what can be the purposes? Experiments and surveys. Experiments used for fundamental research and surveys used for operational research. What is secondary data? Data collected from records, mainly on observation as a routine process, such as records. So broadly, data sources are of two types. One is primary and another one is secondary. The primary data means data which is collected for that purpose, and for that purpose only it is extracted. Like if you want to go do a research, survey, then you collect for those survey you collect the data. This is primary data. Mainly it is collected from the community, or you directly go to people, traverse say from house to house, patient interview, data collection through a questionnaire for a study. These are primary sources of data. What are secondary sources of data? Data is collected as a routine. So for example, in a hospital there is an outpatient register. When you collect data from such registers or records, health profile, records available in medical records division or MRD, or any other source where data is available before a research is planned, then that source of data is called secondary data, right? Now, statistical data. The statistical data obtained from above sources can be divided into broad categories. Okay, quantitative and qualitative and quantitative. So one is qualitative data, another one is quantitative data. So these are the two broad categories, broad classification of statistical data. Qualitative data, what are the features of qualitative data? It is not measurable. So you cannot directly measure a qualitative data into numbers or values. Classified by counting the individuals having same characteristics, or attributes. Only one variable here can be measured. That is, for example, number of persons and not the characteristics. Okay, so I'll explain that. What is qualitative data? Not measurable. Okay, for example, say a focus group discussion had been conducted. So focus group discussion is a very important tool of generating qualitative data. So we shall discuss about it in our classes regarding epidemiology and research methods. Focus group discussion, we have found that it is usually done from 8 to 12 people. We have found that how many people are having supportive opinion towards towards an towards a community intervention. So we have the number, say out of 12 people, 4 are supporting, 8 are not supporting. 4 are yes, 8 are no. So only up to this much. That is the evaluation of the support level. So the support cannot be evaluated in numbers. Like if 4 people are supporting, we cannot put them in a scale. Like number 1 say supporting out of a scale of 10. Person number 1 is supporting 3, person 2 5, person 3 7, person 4 9. We cannot categorize in or express in numbers or grade them in numbers in case of qualitative data. That is why it is said that qualitative data is not measurable. Okay. Now coming to quantitative data. Quantitative data have magnitude measured either on an interval or a ratio scale. Some of the statistical methods employed in analysis of such data are mean, range, standard deviation, coefficient variation, correlation coefficient. So if all these terminology are important, for now we can understand what is the features of, what are the features of quantitative data, and this terminology we shall understand in detail in our upcoming classes. So what is quantitative data? Data have a magnitude. So what I have mentioned here, which is not applicable for qualitative data, is appropriately applicable for qualitative data. For example, in a classroom there are, I'm giving an example, there are 30 students. Now if you categorize them by say average or normal height for age, and how many are below that, how many are above that, then you can categorize, say out of 30, 7 are below normal height for age, the remaining 23 are not. So this is qualitative distribution of data. Now you cannot scale them in a, you cannot put them in a grading scale. Now if you want to put them in a grading scale, you can have like measure their actual height, then put them in a scale. Say student number 1 is here, starting from 0. Student number 1 is here, student 2 is here, 3 here, 4 here, 6 7 8 9 10, accordingly up to the student number 30. So in a increasing or decreasing scale you can categorize them, and if you have their height values, so you can have mean out of it, mean, mode, median. You can have measured these averages because you know value of each student's height. So what is mean? If we have idea, you can tell that mean is say total of the height of all the students divided by number of students. Okay. So average or height. Now from these we can also measure standard deviation, standard error, correlation coefficient. These can be measured from quantitative data. So this is the basic difference between qualitative data and quantitative data. Qualitative data you can only categorize it, but you do not have individual values. You can put them in different categories. That is why it is individual values are not measurable. In quantitative data, individual values can be expressed in numbers because individual measurements are taken in quantitative data. So we can scale them in a ordinal scale, interval scale. We can have the mean, mode, median, standard deviation, standard error, correlation coefficient measured from the qualitative data. From the quantitative data, but in qualitative data we cannot measure these things. Now, methods of presentation. There are two types of methods of presentation. One is tabulation and next one is drawing. So, tabulation, preparation of frequency distribution table is the first requirement of presenting large quantity of data. Okay. So, what is a frequency distribution table? Say, out of 30 children, okay, how many are male, how many are female? 30 children in a class, how many male, how many female? So, frequency of observing a male child, say, out of 30, 20 are male, 10 are female. So, this 20 out of 30 is the frequency of male, female. So, when we tabulate the data, say, male, female, we are distributing them like 20 and 10. So this is a frequency distribution table. We are distributing the frequency of one observation or one attribute and measuring counting the number of that observation or attribute and distributing them in a table. This is called frequency distribution table. It groups large number of series of observation to master table and presents the data very concisely, giving information at a glance. So just say from here, at a glance we can understand how many male, female. Total also we can understand if we keep the total here. Okay. So we understand that there are two types of observation among the students. One is male and female. How many male, how many female, total how many. We can find out at a glance from this frequency distribution table. So this is tabulation of data. Number of persons in each group is called frequency of that group. So we have mentioned that it records how frequently a characteristic of an event occurs in persons of the same group. So very much understandable. I'll explain this part separate with another example. So how frequently a characteristic of event occurs in persons of the same group. Okay. Say in a slum area, there are 100 children below 5 years of age. Okay. Now frequency of acute respiratory tract infection among these children. Okay. So if you differentiate into a frequency distribution table, how many had, say you want to categorize, we normally it says that upper respiratory tract infection, acute respiratory tract infection more than 5 episodes in a year is very high. Okay. So we categorize them like high frequency, normal frequency. So out of 100, say 60 having high frequency, 40 having normal frequency, total children are 100. So here we are measuring among the children in that slum area the frequency of the event called an acute respiratory tract infection, right? So this occurrence, the frequency of such occurrence is counted and it is mentioned in this frequency distribution table, where we can find at a glance that how many children there, 100 children are there, out of 60 having high frequency, 40 having low frequency. High frequency we understand more than 5 episodes in a year, low frequency less than equal to 5 episodes of upper respiratory tract infection in a year. So that is how we measure it. Okay. Now, broadly understanding what is a frequency distribution table. What is a frequency distribution table? So let us understand in detail. Or frequency table, we can also call it as frequency table. Qualitative data is much simpler to present as there is no notion of magnitude or size of attribute. For the same reason, presentation of qualitative data is more cumbersome. Quantitative data is more cumbersome. Why? Because qualitative data, there is not much, there will be one or two attributes and we can categorize the data, the observations into different attributes. That is much we do. There is also the presentation is not very cumbersome. Why qualitative data is very cumbersome? Because many observations, every observation will have its value and it will be on a ascending or descending order, so it will be a huge master table. Now in quantitative data, the variable characteristics are continuous. They have a range from highest to lowest. Okay. This range is divided into sub ranges or groups, and sub range frequency called class frequency is noted opposite each group. The upper limit denotes up to but not including it. The interval from one sub range to next sub range is known as group of class interval and is equal throughout. So interval from one subrange to the next subrange is known as group of class interval and is equal throughout. So how to explain this? Say in qualitative data. Again coming to the same example, 30 children in a class. They appeared a mock test. 30 children in a class, they appeared a mock test. Okay. Pass marks 10 out of 30. Okay. How many have scored more than 30 or passed and failed? So binary distribution of quality. Third out of 30, say 25 have passed, 5 have not. This is the qualitative distribution data. Now if I categorize this, try to collect individual marks obtained, then what we shall do? We shall list them as per their roll number. Say roll number 1, 25 marks, roll number 2, 16 marks, roll number 3, say 18 marks accordingly, up to roll number 30, say 21 marks. This is how we do. So this is a master table. We can arrange them ascending and descending order also of marks. Say highest mark is 25, say 25, roll number 1, 25, then say roll number 30, 21, then say roll number 3, 18 marks. That's a roll number 2, 16 marks. So we have arranged them in descending order. Okay, that is how we present. So this is very cumbersome. It will give a huge table. Say this is only for 30 children. Say if it is for a census, for a state it will include say 1 crore population. So you can imagine how the data will look like. 1 crore population, say annual income. So annual income of 1 crore people will be listed like this. So you can imagine that how the master chart will look like. So for say, in such cases, frequency table becomes very very important. Say if you want to categorize how many people are out of this 1 crore population, how many are below poverty level, above poverty level. You categorize according to that. Or say more than 1 lakh between. So this is a frequency distribution table where below poverty level and above poverty level. Okay. Now sub frequency level. Say among the above poverty level you want to categorize more than 1 lakh 1 lakh income, then say 50,000 to 1 lakh per month salary. Then say less than 50,000 per month salary. So this is a among the above poverty population we have categorized into sub frequency table. Okay. You can also categorize them into intervals. Say this is an interval. Or say you want to categorize into that 50,000 to 1 lakh into say there are 30 lakh people. You have to categorize them into different frequency. Say 50 to 60,000, 60 to 70,000, 70 to 80,000, 80 to 90,000, then 90,000 to 1 lakh. So this is an interval. In this interval also we can arrange the data. That is how to make an easier and understandable presentation we use the frequency table in case of quantitative data. Right? Rules of making a frequency table: class or group interval should not be too broad, okay, or too narrow. So something meaningful in the group interval should be used. Number of groups or class should not be too many or too few. Too many stratification, then it will become very much similar to what is the master table itself. Say there are 200 people. If I use 100 types of groups or categories, then it is of no use. So for 200 people I can use some 3 to 4 groups. So it becomes understandable and easily presentable. Class interval should be same throughout. So this is something which is theoretical. We can also choose a class interval depending on something meaningful epidemiologically. Headings of class or group should have clear measuring unit. Right? Say income should be in rupees. It should be clear that everyone's income has been mentioned in rupees. The rates of proportion, if given, the actual number in the group must also be noted, which may be done in parenthesis. Group should be tabulated in ascending or descending order from lowest value in the range to the highest. Okay. So I hope it is understandable to everyone. So how it will be done? Group interval. Say 200 employees in a company. Okay, their experience, work experience is going to be measured. Right? Measuring their work experience. So in an ascending order, say we are putting the employee number 1, 2, 3 to the 200 numbers of employees. So for presenting in the frequency distribution table, we should choose frequency intervals which should be equal. Say 1 to 5 years of experience, 5 to 10 years of experience, 10 to 15 years of experience, 15 to 20 years of experience. In 4 categories we shall, and say more than 20 years of experience. In these 5 categories we can distribute the data and mention the number of employees based on their experience. Say 1 to 5 years, say 20, 5 to 10, 30, 10 to 15, say 5, and accordingly we shall distribute. And also so the groups also tabulated in ascending order or can be tabulated in descending order, right? So that is how. And they are clear units. Say experience in years, experience in completed years. This is some sort of uniform and clear unit of expressing their experience. Tabulated in ascending and descending order. And actual number of groups must also be noted, which may not be done in parentheses. So number of groups also to be confirmed before designing them into categorizing them in the ascending or descending order, right? Now frequency distribution diagrams. Presentation of quantitative, continuous or measured data is through graphs. Various graphs we can use. So we have to understand which graph is which one, so that in image based question also one particular graph can be given. And also those who are doing undergraduate study, you will be asked in a statistical class and exam to draw a histogram of a particular type of graph out of a given data. So we shall understand various type of graphs which are used for presentation of the quantitative data. I have named a few here. Number 1 is your histogram, frequency polygon, frequency curve, line chart or graph, cumulative frequency diagram, then scattered or dot diagram. Okay, histogram, frequency polygon, frequency curve, line chart or graph, cumulative frequency diagram, scatter or dot diagram. These are the diagrams which are used. Understanding histogram. See, this is a histogram. Okay. Things to be noted here. Say, number of observations in the vertical line and variables in the horizontal x-axis, all called abscissa. Okay, frequency interval you can see uniform frequency level 60 to 65, 65 to 70, 70 to 75, 75 to 80, 80 to 85, 85 to 90. It is histogram is a type of area diagram. Frequency of each group will form a column or rectangle. See, rectangular columns have been formed for each frequency distribution. The height of rectangle alone will indicate the frequency when the class interval is uniform. So height is variable based on the observation, which is according to x-axis, how many observed frequency are there, and class interval is uniform. Yes, 5. Class interval is 5. So let us make a histogram through an example. Say, So how many are there? Let us come to, say, in a village. We are examining 100 people who are smokers. Okay, 100 smokers. And we have to say various things like uh, relation of smoking with their age. So first we have to understand their age distribution, and we have to express it in the form of we can express in the form of a histogram, the age distribution. Okay, so we shall plot it. Say first we shall decide the frequency interval, the class interval. We shall decide the interval of the class is here the age. So age in years, we can categorize them. So 100 adult people, that means, say we are taking population, say more than 50 years of age, starting with starting population inclusion criteria is those more than 50 years. Such 100 people we have to have chosen. So, and the upper limit is here, say 95 years. Okay, so frequency the class interval can be, say, equal, say 50 to 60 years, 60 to 70 years, say 90 years. So 70 years, 70 to 80 years, 80 to 90 years. In four categories we need to classify. We have plotted it as per the x-axis or abscissa, and the frequency we shall measure as the y-axis. So this is the frequency interval. So how the histogram looks like? Say 50 to 60, there are 30 people. So this is 30 here. So it will be a rectangle like this. Okay. Now say 60 to 70 is 40 people. 40 is here on the y-axis. So it will be like this. 70 to 80, say 20 people. In the y scale it is 20 is here, 20 people. 80 to 90, say 50 people are there. Total 100 people, right? So 90 people already covered, so it is, say, 10 people. So it will be here, 10 people. So say rectangular bars y-axis as per along with the y-axis we have plotted the frequency and the value of the class interval as per the x-axis. This is a histogram, right? Now coming to this is a frequency polygon. This is also an area curve, area diagram developed over a histogram by join the midpoints of the class interval at height of frequency by straight lines. The midpoints of the class interval have been joined by straight lines to form the frequency polygon. It is a polygon, that is figure with many angles. Say straight lines have been joined, so angles have been formed. So when two straight lines will join, angle will form. For example, in this, the midpoints of the histogram of the class interval of the histogram will be joined by various straight lines. Say from here to here, here to here. So one angle from here to here, another here to here we have reached. From here to here, another angle formed, another angle formed. That is why frequency polygon. So coming to this is another frequency polygon. Okay, line chart or graph. It is nothing but in the y-axis the variable and x-axis the frequency. Frequency may or may not touch zero. It is a poor diagram where 0 is not touched because it does not lead to a comparison. So we shall explain this. So this is a line chart or graph. How it is drawn? Say 10 boys in a basketball team. Their height in centimeters are to be plotted in a line diagram, line chart, or in a graph. So height can never be 0. That is why it will not touch the 0. So as per y-axis, let us plot the height. And in the x-axis, we shall plot the observation. So there is no class. It is individual observation. In histogram and frequency polygon, what we have seen, we had a class interval and the class was plotted as per x-axis. Here the individual will be plotted as per x-axis. So in 10 boys, boy number 1 height starts from here, boy number 2 height starts from here, boy number 3 here, 4th here, 5th here, 6th here, 7th here, 8th here, 9th here, 10th here. These will be joined by smooth curves, not by straight line. It will be joined by smooth curve and a graph will come. This is a line chart. So we see these things in say in case of a cricket match. Over number 1, 3 runs scored over 4, 5 runs scored over 3, again 4 runs scored over 4, 5 runs over 5, 7 runs scored. Accordingly, it is plotted in a graph which is visible in a cricket match scorecard, right? Cumulative frequency distribution Ozive. This is very important. So one point is missed here. It is never 0. So we cannot compare like in comparison to boy 1, boy 2, how many times high, how many times taller. This cannot be compared in such manner. When the chart, the graph does not touch 0. So there is a limitation of the line chart. So cumulative frequency distribution Ozive. There is a cumulative frequency distribution Ozive. What is that? In such graphs, cumulative frequency of observations is plotted as per y-axis and variables in the horizontal axis or x-axis. So here also there is no class interval. All the observations are plotted as per the x-axis. To draw this, an ordinary frequency distribution table in a quantitative data has to be converted into a relative cumulative frequency table. So here we shall consider the cumulative data as the frequency advances, observation advances. We shall keep on adding the frequency and we shall be putting the plotting the cumulative frequency on the graph. How we shall do it? Say for 10 boys in basketball team, their height in centimeters. So say first one 100 centimeter, just assume 105 centimeter, 3 107 centimeter, ascending order we are putting it, 107 centimeter, 108 centimeter, fifth one 109 centimeter, sixth one 110 centimeter, seventh one 111 centimeter, eighth one 113 centimeter, ninth one 115 centimeter, 10th one 116 centimeter. The ascending order, this is the height of the boys. So y-axis frequency, x-axis individual observation. So it will never touch 0, start from 100. Boy 1 100, boy 2 it will never come down because it is the ascending order and cumulative. Boy 2 cumulative frequency 205. It will reach here 205. In third observation 205 plus 107 it will be 312. So it will reach here. Fourth one 312 plus 108, it is 420. Say here. Next one is 420 plus 109, say 529. Reaching here. Second one is 529 plus 110 cumulative, so it will be 639. So here 639 plus 111, so it will be 750 here. That is how the graph is going in a cumulative frequency. Such cumulative frequency graph or Ozive looks like this. Sometimes it is also negative frequency. So total frequency, we start with the total one and we come down by deducting the previous frequencies. So it comes downwards. So negative frequency distribution, positive frequency distribution table and negative frequency distribution table. So this is the positive one and the one coming down is the negative frequency distribution table. Scatter diagram or XY diagram. Frequency of variables in y-axis, frequency of variable 2 in x-axis. So here typically two variables are observed and their frequencies are plotted in a randomly on a table, randomly on a graph. Now varying frequency of the characters give a number of such points or dots that show a scatter. So it will be, dots will be scattered. Sometimes it can show a pattern, a line or drawn to show the nature of correlation. Sometimes they make a pattern, is called correlation, positive correlation, so going upwards, negative correlation coming downwards. So what we do here, say two observations together, for example age and height, say height for age. Okay, let us do it here. Height for age for 100 children. So someone's, for say we can choose either way. Say for y-axis we are putting height, x-axis we are putting the age in say months. Okay, for less than 5 years children we are choosing the months. So for child 1 it is here, child 2 it is here, child 3 it is here, child 4 it is here, child 6 it is here, child 7 it is here, child 8 it is here, child 9, child 10. That is how it goes. So we can show it in a correlation positively. So what we understand, as the age increases the height also increases. So it is a positive correlation. Okay. So we shall give an example of negative correlation. Negative correlation. For example, age against age with, say, kilometers walk, capacity to walk kilometers. So say x-axis, y-axis, x-axis we are putting age, y-axis kilometer covered with walking. So as age is less, capacity will be high. Age is increasing, capacity will be reducing. So it will be a scattered diagram, but it will have a pattern. Like as age increases, the capacity of walking, covering kilometers through a walk will gradually decrease. So the graph will be, with the advancement of age, graph will be downwards. It is a negative correlation. Okay, so I hope it is now clear to everyone. Coming to bar diagram. So bar diagram is nothing but individual observations. Instead of putting in a graph for individual observation, the values are shown as bars. Okay. So here, say in the bar diagram, say with age, same thing if we put age and kilometers covered by walk. We can show individual observations by bars. Okay. So it looks very much like histogram, but it is not to be mistaken, it is not a histogram. It is a bar diagram. What is the basic difference between histogram and bar diagram? Histogram and bar. What is the basic difference? See, in bar diagram, we are plotting individual observations. Against x-axis in case of bar diagram. In histogram, what we are doing? Histogram, we are putting frequency interval. So this is the basic difference between bar diagram and histogram. Next is pie chart or scattered sector diagram. So it is nothing but a universe is considered as 360-degree roundup. Okay. So we convert the observation into percentage, and that much percentage of 360-degree angle is chosen. Say in India, there are people of 5 religions: Hindu, Muslim, Sikh, Buddhist, Christians. Say Hindu 70%, Muslim 20%, Sikh 5%, Buddhist 2.5%, Christian 2.5%. So in a pie chart, 360-degree, say out of 360-degree, Hindu will be 360 into 70%. This much, say, for Hindu. Muslim 20% of it, Sikh 5% of it, Buddhist 2.5%, and Christian 2.5%. That is how it is plotted in a pie chart. So you can show it in different colors so that we can differentiate and label it. That is how a pie chart is drawn. So in your exam you will be asked to draw a pie chart. A pictogram or spot map. It is nothing but plotting the data in a map. For example, how many cases of malaria observed in various states of the country. So we have a map of the country. There we can plot the number of cases, or we can express by different colors. Say less than 1,000 cases, this faint red, gradually grades can increase, or different colors increase for increasing number of cases. Pictogram expressing the data in case with pictures. Say epic popular method to impress frequency. So body of a human being has been shown, and the organ affected by COVID-19. So how many people are neurologically affected? So against the brain it can be shown. How many people respiratory system was involved? Against the lung it can be labeled. So also accordingly GI system, renal system, musculoskeletal system, and peripheral nerves. That is how the frequency can be shown in a picture. So these are what is a spot map, and another one is pictogram. So with this, I have expressed various method of expressing your data, the various sources of data. So I hope that all of you have understood what has been explained. So I'll be continuing to give you such videos in relation to various parts of community medicine in my upcoming classes. So I would like all of you to give comments in the comment section, so I can find out various ways of improving my upcoming videos. And I will also request to share the data, share this video if you like the video, and to also if you want other people who can be benefited with this video, so that it reaches to them. And if you like the video, you can also subscribe my YouTube channel. So thank you everyone for watching the video.